now we're going to look at something in reverse order to what we've been learning. Now, this is known as anti-differentiation, and essentially it's working in the opposite direction of what we've been doing. We have been differentiating functions this whole time, okay? And we've gone to the first derivative, second derivative, we've even gone to third and fourth sometimes. Now, we're actually going to learn the process of the reversed order. Now, this is very, very important, just the understanding, and that's why I'm just taking a little bit of time to explain it, is that this anti-differentiation is known as integration. And this is very, very important for the rest of your mathematical understanding. It comes up over and over and over again. But just to pave the way of how we come to it, okay, I've just got some examples here. If we were to differentiate these, y dash would be, the 3 would go away, and then we were left with 2x. If we differentiate this, y dash, 6 would go away, we're left with 2x. If we differentiate this, it's going to be y dash 2x. They are all the same results, but we have 3 different functions. And we'll just like, okay, therefore differentiating it gives us all these, but if we were to go the opposite way, how could we do that when we've got 3 different numbers here? So we're like, okay, we're stuck with a problem. Okay, let's deal with one problem at a time though. If, let's say, I asked you to take this and make it into the original function, most of you could look at that and go, well, I know differentiating is pulling down the indice and putting it at the front. So really I've got to do the opposite of that. I've got to take what's out the front and put it back on top. I was like, okay, how do we do that? And also we've got to, and something more important I guess, is you've got to plus 1 to the indice. Okay? Because that's what we're doing. We're always minusing 1 from the indice and bringing it down. So we needed a procedure that accounts for these 3 issues. We need to take what's in the front and put it back up, and also plus 1. So that's kind of one thing we need to do at once. And we need to incorporate this missing number. The way we're going to write this is y dash if it equals xn. Okay? Similar to our x squared or 2x or whatever. Then what we actually want to do is, if we're doing y, we want to get our x, our n, we want to plus 1. Okay? Because we've been minusing 1 all this time, it only makes sense to plus 1 if we're reversing the order. Now to get rid of the number at the front, therefore we want to divide it by the plusing 1 of that indice. Okay? And I'll show you in the example in a second. And the last thing is to incorporate the number. We don't know what the number could be, but we can just put a placeholder. This is going to be our new letter C. And that stands for constant. Okay? And the way we fill this in, the question needs to give us more information to solve it, but we need a placeholder for these numbers. Now, I want to show an example of how this works, specifically with these very easy ones. The placeholder question I'm going to get to later, okay? But you've just got to reserve this spot for any numbers that could appear. You just need more information. But let's do this one real quick. If I have this, okay, or my 2x, my y dash is 2x. To get it back to its original function, there's a 1 here. I'm going to plus 1 to this. So it'll be x squared, 2, and then I'm going to divide it by n plus 1 plus c. Now 2 divided by 2 is just going to be x squared plus c. So here we go. We have x squared plus c. Now, it still doesn't quite fill the whole function, does it? It only gives us this first bit, but it's halfway there. If the question was to give us further information and say that the y-intercept was 3 or 6 or minus 4, then we can plug that in and give us our c. Okay? But this is just introducing you to the idea of anti-differentiation and integration, sorry. So I just need you to understand how that works. I especially want you to write this in your books and put it somewhere very important, because you are going to be referring to this over and over and over again. And this is going to be really confusing because you've learnt differentiation this whole time, and now you've got to learn the opposite direction of that. So I really want to make sure you've got differentiation down packed before moving on, because this does get a little bit more harder and there's a lot more rules here.